The year is 1100. Amid rain-lashed stone hills, you stand beside the medieval stone castle walls, confronting constant siege impacts, fire projectiles, undermining tunnels. The medieval stone castle formed limestone ashlar walls, thickening outward. So each successive masonry course dispersed trebuchet stone energy across expanding mass, instead of concentrating fracture through single planes. The medieval stone castle extended those ashlar faces downward into tapered curtain wall bases, widening the load footprint, so bombardment compression traveled outward into ground rather than collapsing vertical courses. Within the medieval stone castle, rubble core infill, packed between dressed stone faces, compressed upon impact, converting sudden shock into distributed granular movement that slowed crack transmission. Binding that rubble, the medieval stone castle relied on lime mortar joints that flexed microscopically, allowing masonry courses to shift without shearing apart under repeated projectile strikes. Where walls met towers, the medieval stone castle curved tower exteriors, so incoming stones glanced sideways along rounded surfaces, dispersing force instead of shattering flat masonry faces. To exploit those deflections, the medieval stone castle cut arrow slit embrasures narrowly on exterior faces, reducing exposed openings through which direct projectiles could penetrate. Inside the medieval stone castle, those narrow embrasures widened into deep splayed arrow loops, permitting archers lateral aim, while thick surrounding masonry absorbed counterfire impacts. Above those walls, the medieval stone castle constructed parapet crenellations, alternating solid stone merlons with crenelles, creating rhythmic cover for bodies during projectile exchanges. Each merlon within the medieval stone castle thickened beyond wall thickness, so crossbow bolts and thrown stones embedded harmlessly instead of splintering protective masonry screens. Projecting beyond the medieval stone castle walls, stone machicolations extended outward, allowing defenders to drop heavy debris through floor openings directly against attackers below. Protecting the primary entrance, the medieval stone castle raised gatehouse twin towers flanking the passage, overlapping firing lines that trapped intruders within converging stone corridors. Within that gatehouse, the medieval stone castle installed iron portcullis, grates sliding vertically through carved stone grooves, sealing passages instantly against forced entry pressure. Above the sealed corridor, the medieval stone castle pierced vaulted ceilings with murder holes, channeling rocks through stone shafts onto immobilized enemies beneath. Beyond the gatehouse, the medieval stone castle spanned its dry moat using a drawbridge timber deck, pivoting on stone abutments anchored into massive masonry piers. Below that bridge, the medieval stone castle shaped moat, scarp walls steeply in dressed stone, eliminating footholds where ladders could brace against vertical surfaces. To preserve those steep faces, the medieval stone castle lined ditch revetments with ashlar stone, preventing erosion from repeated flooding used to weaken siege works. Along the wall tops, the medieval stone castle paved curtain wall, walkways and stone slabs, spreading concentrated marching loads across structural masonry beneath. To protect those slabs, the medieval stone castle carved parapet drains through masonry, channeling rainwater outward before it dissolved mortar joints behind battlements. Inside vertical circulation, the medieval stone castle rotated spiral staircases clockwise, forcing intruders' sword arms inward, while defenders used central stone newels as shields. Anchoring everything above, the medieval stone castle bedded keep foundations directly on solid bedrock, preventing undermining tunnels from collapsing load-bearing walls. When mining attempts continued, the medieval stone castle extended countermining, tunnels beneath foundations, reinforcing them with stone arches that resisted fire and cave-ins. Above ground, the medieval stone castle added massive tower buttresses, increasing exterior mass that countered outward thrust from impact vibrations along tall walls. Within central keeps, the medieval stone castle built vaulted stone ceilings, redirecting falling debris sideways into thick walls instead of onto occupied floors. Beneath those vaults, the medieval stone castle carved stone hearth flues vertically, venting smoke through masonry shafts without weakening surrounding structural courses. Hidden within wall thickness, the medieval stone castle embedded narrow postern gates, allowing controlled exits, while thick masonry concealed vulnerable openings. Overhead, the medieval stone castle roofed towers with heavy stone slabs, whose weight resisted explosive uplift from incendiaries striking wooden superstructures below. Replacing earlier timber defenses, the medieval stone castle constructed permanent stone galleries projecting outward, providing fire positions immune to burning siege weapons. Between those projections, the medieval stone castle staggered curtain wall offsets, creating angular killing zones where attackers faced crossfire from multiple masonry faces. At structural junctions, the medieval stone castle thickened corner quoins, concentrating reinforced stone where stress accumulated between towers and connecting walls. Behind those walls, the medieval stone castle packed rubble ramparts tightly, adding mass that absorbed ramming energy before it reached exterior masonry faces. To support prolonged defense, the medieval stone castle carved stone cisterns beneath courtyards, capturing rainfall through channels embedded within wall systems. Shielding outer approaches, the medieval stone castle raised, sloped glacis earth banks, faced in stone, deflecting artillery shots upward, away from curtain walls. From elevated positions, the medieval stone castle placed arrow loops higher along towers and walls, enabling plunging fire directly down masonry bases where attackers clustered. Within the medieval stone castle, gatehouse vaulted passages slowed attackers beneath stacked stone defenses, forcing constrained movement, while overhead, masonry layers carried load and enabled defenders to fire from protected positions above. Across the medieval stone castle gatehouse, iron-reinforced wooden doors rested beneath stone relieving arches, transferring impact stress into surrounding masonry and preventing concentrated load from compromising structural stability. The medieval stone castle varied wall thickness by exposure, placing heavier masonry toward anticipated siege directions, distributing projectile energy across multiple courses, and reducing localized structural failure. At the core, the medieval stone castle raised keep walls tallest, forming the final refuge enclosure behind massive masonry layers, absorbing repeated bombardment, and supporting defensive fire positions. The medieval stone castle embedded stone corbels within walls, carrying projecting galleries without timber, creating protected overhead positions resistant to fire or decay while maintaining structural load distribution. Within the medieval stone castle, defensive chimneys angled outward, preventing projectile entry through flues and redirecting external forces safely away from internal living and storage chambers. On the medieval stone castle parapets, wall tops surfaced with stone flags, forming continuous walking platforms while preventing fire spread across masonry and maintaining safe defensive circulation. The medieval stone castle embedded timber tie beams within stone courses, locking masonry and reducing shear failure during lateral impact from battering rams or concentrated siege projectiles. Within medieval stone castle towers, floor vaults carried heavy troop and storage loads, transmitting weight through thick masonry walls during prolonged bombardment without collapse or deformation. Stone stair landings in the medieval stone castle widened strategically, allowing defenders to reposition behind surrounding masonry while maintaining continuous movement along interior defensive circulation routes. The medieval stone castle adjusted curtain wall height to match bow range, maximizing defensive reach across approaches while integrating with existing masonry and providing overlapping fields of fire. The medieval stone castle angled tower faces, redirecting battering ram momentum sideways along masonry planes, preventing concentrated impact from compromising the vertical structural integrity of walls. Around firing openings, the medieval stone castle thickened stone embrasure lips, resisting chipping from repeated stone, bolt, or arrow strikes, preserving internal wall stability during continuous engagements. Parapet wall walks on the medieval stone castle were raised, enabling defenders to fire downward over edges, while masonry merlins shielded soldiers from return fire. Medieval stone castle drawbridge chains anchored into massive stone sockets, transferring pulling tension into solid masonry, preventing failure under repeated raising and lowering during active defense. At the keep, the medieval stone castle elevated the entrance, reached only by removable timber stairs, isolating the primary access point and integrating with surrounding masonry defenses. The medieval stone castle-shaped stone roof pitches steep, shedding burning debris quickly, preventing fire from reaching masonry joints while protecting interior spaces from ignition hazards. Inside medieval stone castle towers, spiral interiors narrowed, forcing attackers into single file beneath arrow fire, while masonry walls absorbed lateral movement pressure and supported overhead vault loads. Medieval stone castle stone vault ribs channeled ceiling weight into thick load-bearing walls, distributing vertical pressure across multiple courses and maintaining structural integrity during prolonged bombardment. On medieval stone castle curtain walls, coping stones overhung exterior faces, shedding rainwater from mortar joints, preventing erosion while maintaining defensive parapet walking surfaces. Murder hole shafts in the medieval stone castle were lined with stone, preventing fire erosion and maintaining ceiling integrity during repeated defensive liquid pours. Gatehouse portcullis slots in the medieval stone castle were reinforced with dressed granite edge blocks, preventing wear and structural failure from sliding iron grates under attack. Near foundations, the medieval stone castle compacted wall core rubble tightly, resisting undermining collapse by distributing stress through the masonry while maintaining overall wall stability. Medieval stone castle tower windows, set high, prevented ladder access to interior chambers, integrating safety with defensive fire while maintaining vertical load support. Stone parapet. Thickness increased at corners in the medieval stone castle, absorbing concentrated strikes from projectiles and maintaining structural integrity along angular masonry intersections. Keep corner towers in the medieval stone castle projected outward, flanking adjacent curtain walls and creating overlapping defensive fields of fire across multiple stone planes. Ashlar bonding patterns in the medieval stone castle alternated courses, locking exterior faces to rubble cores, distributing weight and resisting separation under repeated impact. Defensive latrine chutes in the medieval stone castle dropped waste outside walls, maintaining hygiene and preventing interior buildup, while keeping masonry openings sealed against attack. Stone scupper holes pierced battlements in the medieval stone castle, draining rainwater and liquids from defensive platforms without weakening surrounding masonry or walking surfaces. Outer bailey walls in the medieval stone castle were lower, drawing attackers toward inner stone traps and coordinating with higher masonry layers for controlled defense. Keep basement vaults in the medieval stone castle were strengthened, storing supplies beneath thick masonry that transmitted weight safely and prevented collapse under pressure. Wall walk guardrails in the medieval stone castle were built from stone, preventing falls during combat movement, while integrating seamlessly with parapet masonry. Tower roofs in the medieval stone castle were conical, shedding arrows and burning pitch downward, preventing ignition of timber structures while maintaining overall defensive stone integrity. Within the medieval stone castle, curtain wall batter slope increased significantly, resisting scaling ladder effectiveness, forcing attackers to climb outward. Leaning masonry, while distributing vertical and lateral defensive wall loads carefully across full thickness. Gatehouse murder slits in the medieval stone castle were angled precisely, targeting chest height through narrow corridors, allowing defenders to fire safely, while stone walls absorbed recoil and lateral impact efficiently. Stone stair newels in the medieval stone castle were extremely thick, acting as structural compression cores, supporting spiral masonry and maintaining staircase stability under continuous troop weight and repeated heavy movement. Inner ward paving in the medieval stone castle was laid meticulously with stone, preventing mud accumulation that could slow troop movement, while integrating securely with surrounding masonry foundation layers. Tower embrasures in the medieval stone castle widened internally, allowing crossbow cranking clearance space, maintaining wall integrity, and providing safe maneuvering room for defenders within thick and solid masonry surrounds. Stone plinth courses in the medieval stone castle raised walls above standing moat water, preventing erosion at masonry bases while distributing vertical loads evenly across underlying foundation stones. Wall crown crenels in the medieval stone castle were deliberately narrowed, minimizing exposed defender silhouettes while maintaining open firing positions across the exterior wall for fully protected defensive operations. Keep vault keystones in the medieval stone castle were deliberately oversized, locking arch loads securely into surrounding stone, distributing vertical stress safely throughout thick masonry vault structures. Stone sally ports in the medieval stone castle were deeply recessed, disguising entrances within wall thickness, limiting attacker visibility, and integrating with surrounding masonry to maintain long-term defensive integrity. Outer wall faces of the medieval stone castle were smoothed extensively, reducing grappling hook grip points, while preserving precise load transfer between ashlar courses and rubble cores. Gatehouse ceiling vaults in the medieval stone castle were layered thickly, resisting fire and collapse, while transferring vertical and lateral loads efficiently into supporting masonry walls. Stone benching along medieval stone castle walls supported heavy stored missile piles, distributing concentrated weight into adjacent masonry and maintaining stability across defensive platforms during prolonged combat. Tower foundations in the medieval stone castle were carefully stepped, following bedrock contours, preventing slippage and transferring vertical load evenly across irregular underlying stone layers. Curtain wall tie stones in the medieval stone castle spanned full thickness, bonding exterior ashlar faces to rubble cores, integrating the masonry into a continuous and stable structural system. Stone hoarding slots in the medieval stone castle were precisely cut to accommodate removable timber siege galleries, projecting outward while resting securely on embedded masonry supports. Gate passage floors in the medieval stone castle were carefully sloped with stone, draining boiling liquids outward, preventing pooling that could damage masonry or impede defensive operations efficiently. Tower interior shafts in the medieval stone castle were vertical, enabling rapid rope communication drops, while masonry edges contained wear and stress from repeated daily use. Wall embrasure bases in the medieval stone castle were angled appropriately, shedding water from weapon rests, preventing mortar saturation, while maintaining defensive firing platform integrity. Keep wall niches in the medieval stone castle were carved into masonry, storing weapons safely within protected chambers, while preserving wall load distribution and defensive capability. Stone parapet merlons in the medieval stone castle were securely capped, preventing weather erosion from weakening edges while maintaining height and stability across battlement defenses. Curtain wall offsets in the medieval stone castle were staggered, preventing straight ramming approaches and forcing attackers to navigate controlled angles across multiple strong masonry planes. Tower upper floors in the medieval stone castle were deliberately smaller, reducing mass on lower vaults and transferring vertical loads safely through supporting masonry walls. Stone foundations in the medieval stone castle were widened outward substantially, distributing vertical load pressure over bedrock and preventing settlement beneath concentrated masonry masses. Gatehouse door pivots in the medieval stone castle were securely set into massive stone hinge blocks, transferring dynamic load from swinging doors directly into surrounding masonry. Wall tops of the medieval stone castle were coated carefully in lime wash, reflecting heat from incendiary attacks while preventing mortar degradation across exposed masonry courses. Tower stair arrow loops in the medieval stone castle were precisely positioned, covering every landing turn, allowing defenders to fire safely while masonry absorbed lateral force. Stone drainage culverts beneath the medieval stone castle walls relieved accumulated groundwater pressure buildup, preventing wall base erosion and maintaining surrounding masonry structural integrity. Keep rooftop stone gutters in the medieval stone castle channeled rain efficiently into internal cisterns, protecting parapets and storing water for defensive operations. Curtain wall core gravel in the medieval stone castle was mixed deliberately, improving shock absorption properties and distributing impact forces safely through surrounding masonry. Gatehouse side chambers in the medieval stone castle housed winches securely within thick stone protection, isolating mechanical stress while preserving overall masonry strength. Tower embrasure sills in the medieval stone castle were sloped outward, directing blood and rain away, preventing mortar saturation and preserving defensive firing surfaces. Stone wall faces in the medieval stone castle were replaced periodically, maintaining smooth defensive surfaces while preserving load transfer between courses and internal masonry cores. Keep buttress bases in the medieval stone castle were deliberately broadened, countering outward vault thrust forces while transferring weight safely into lower masonry layers. Stone parapet walks in the medieval stone castle were widened substantially, supporting heavy artillery placement while maintaining structural integrity across battlement masonry courses. Viewed across the expanse of the medieval stone castle, each wall, tower, and parapet presents a network of interdependent adaptations responding to precise physical pressures. Every batter slope, every ashlar course, every vaulted ceiling, and each mortar joint record solutions to concentrated impact, lateral thrust, and repeated human load. Gatehouse passages, murder holes, and sally ports demonstrate spatial control of movement while maintaining structural continuity across masonry. Towers with spiral stairs, embrasures, and internal shafts integrate defensive function directly into their vertical geometry, while floor vaults and ribbed ceilings distribute weight efficiently. Curtain walls, offset and reinforced with tie stones, link with plinth courses, coping stones, and hoarding slots, forming continuous layers that distribute both attack forces and the stresses of accumulated mass. Stone parapets, merlons, and crenels operate simultaneously as firing positions, drainage channels, and weatherproofing devices, while foundations follow bedrock contours to stabilize the entire mass. Keep walls and corner towers concentrate height where refuge is required, integrating roof pitches, gutters, and cisterns into a self-supporting defensive network. Mortar joints flex under lateral stress. Rubble cores absorb kinetic energy, and lime wash preserves exposed surfaces. Every opening, from arrow loop to postern gate, has been placed to balance access, fire coverage, and structural integrity. In this system, repeated experimentation, observation, and refinement are embedded into the fabric of stone and mortar. The castle endures not as a symbol, but as a precise articulation of the interplay between human construction and physical forces, each component a recorded outcome of necessity and engineering. In the quiet after siege or storm, the walls remain intact, the vaults bear their weight, and the parapets continue to channel rain and wind. Here, in measured stillness, the medieval stone castle stands, a cumulative record of design responding to challenge, a testament to human material adaptation, and an enduring alignment of construction with environment.